So hello everyone, in this video we'll be learning about how you can convert a Pearson correlation coefficient formula into like a Python function. Like we all know that Pearson correlation coefficient is used to find if we have two variables like the x variable and the y variable. So if you will change the x variable, by how much quantity the y variable will change will be the Pearson correlation coefficient of that. And this is the formula to find like this change. I think it is visible on the screen right now. This is the formula, we have to just find the summation of xi minus x bar. We know that for every data point, like for 10, 20, 30, we have to subtract the mean value. X bar means mean value, and then again yi minus y bar. This y bar is also for the mean value of the this y thing. And again we have to divide it by xi minus x bar whole square, like of summation. It is the we can simply see that it's a variance of x and into the variance of y. So basically this is like a covariance of x and divided by variance of x into variance of y root under. So we are simply finding this thing. So what does this mean, like why it is used? So it is useful when you are just finding this thing, base fit line for the linear regression model. When you are just training the data, whenever you are putting the data into the linear regression formula, it is basically finding that thing using the correlation coefficient, like how the data is like dependent on each other. By using this, further we will be finding the value of y is equal to mx plus c, the value of m, that is the slope, that we will be finding, how the data is related. So basically based on that we can find is it a linear is there any linear relationship between the data variables or not. So basically how we can find that, so by using Python. So we'll be converting this formula, this uh, formula into the Python function. So first we'll just try to move this thing, okay, below, so that we can take references like whatever we are making. So first of all, let's define the helping function, like mean. Like we know that x bar is the mean. So for finding the mean, we have to define the mean function, and there will be the list going inside the mean. Suppose that is x, and it will be returning. In the last video I have also explained like how to make the mean formula, but we are also making a like mean, and then mean is equal to sum of x divided by length of x. So whatever we will be passing in this function, that will be like finding the mean. And the next thing that we are going to make is like for the Pearson correlation. So we'll be making this Pearson correlation, okay, here we have, and we'll be making x and y. So this is the any name that you can take, like I have taken a Pearson correlation. You can take any name, P, C, yeah, anything that you can remember. So the first thing that I can remember, we have to find the summation. So summation is from I to n. So for n you have to first define what is n. N is basically length of x, and if you know the length of x, we also know that in a, like if you are finding for the pair of two variable, the length of x and y is same. Like we have x as much as we have y. So we can only take for the one variable. We can take also for the y. I'm taking for the x. And then what we have to find, like in the formula we can see we have to find the mean, mean of x and y. So we can simply find the mean of x is equal to mean of x, and mean of y is equal to mean of y. Here we are using our function that we have made here. So we are not importing any function. We are just trying to make our own function. Okay. So the next thing that we'll be doing, like we have to find for the numerator and denominator. I will do it separately. So for the numerator, I hope the spelling is correct for the numerator. Like in variable, it doesn't matter. Like if I can only write anything, but I want to just make it human readable. So sum of square. You will understand why I'm just making this. I will also explain later, like why I'm making this much of variable. It will just help to like reduce mathematical complications. So we have defined here three variables. Like the one is numerator, The next thing is sum squared x. Like see, here we have summation over all these terms, but here what is the different thing is like we have summation on x thing and then again summation of y thing. So first we'll find this thing and store in the sum of square x, and then first and again we'll find this thing and store in sum of square y, and then again multiply both thing, and we'll find the root and we'll store in the denominator. We can also make a denominator variable, so let's make it denominator. First we are starting with 0, as we know that denominator can't be 0, but we are starting with the 0, or we can remove that. So we can do anything, so let's keep it, we'll change it later. Okay, so now we know that for the summation is like a loop. Like you know that for every I we have to calculate this and then again sum all of that. So what we'll be doing, first we'll be like for I in range, and here we will use our n. Why we have like made this n for this thing, like to use it here. And now we'll just uh, we can like check for every x I minus x bar. So let's store in anything. Let's say dx is equal to for every I we are going to extract the value from the list and subtract the mean value, like mean of x. So here it is, and dy is equal to we are going to do this from the y variable and then minus mean of y. So here we have dx and dy, and it will be like getting all the value, and what we are doing, dx into dy. So in the numerator plus is equal to dx into dy. Let's put in the like small bracket so that it will be like not confusing, so it will be easy. And for every sum of a square x, what we are going to do, we are going to store in the sum of square x variable plus is equal to dx into double star, like to the power. Like why we are doing this, like see, xi minus x bar is same here, like dx is equal to xi minus x bar. See, xi minus x bar is equal to dx. So what we are doing, we are just doing this square of that, and again storing sum of square y plus is equal to dx to the power 2. So and at the end it will be not happening in the loop, like summation we will find this value and this value at the end, but after this loop what we'll be doing, we'll be just making the denominator is equal to, and we have to use one thing here, like what we are going to use here is we are going to import one thing, that is maths. So what it will be doing, like we know that to make this square root we have to import the math in the Python. So we'll be doing that. So denominator is equal to math dot, there is a function square root sqrtr it is, then sum of square x into sum of square y. Okay, sum of square y, and then we have numerator, we have denominator also, and we'll be returning this thing, return what is the answer, numerator divided by denominator. Okay, so here we have all the things, like Pearson correlation coefficient. Let's test it. It is Pearson correlation, and we have x and y, and what are these value, like we have x value here 10 20 30 40 50, and then y value was let's see 15 25 35 45 and 60. So I think its answer is yeah 1.1. okay, let's check the value. No, the answer should be 0.9958. So I think here we have some mistake, so let's try to find out. So we have mistake here, like we are just doing this sum of the square plus is equal to dx square, and here sum of the square y should be dy square. So it was a simple and easy mistake. So now let's run this. So here we have 0.9958. Yeah, it was 0.9958 that I calculated using like on a paper, like using the function. And here again we are going to get the same value. So this is how you can simply find the correlation coefficient, Pearson correlation coefficient using the Python. So this is how you can make convert that function in the Python code. So hope you like the concept of converting the mathematical formula into the Python code. So see you in the next video. Till then, take care. Bye bye.